Good evening, everyone. Not good evening, man. Good morning. So we are very much used to of conducting our sessions in evening. Anyways, for the very first time, everyone, very energetic. Good morning to all of you. How are you all? So I hope every one of you is doing absolutely fantastic. Meet your chemistry expert Sanjay Arya sir, and today we are conducting our morning session on redox reactions, and we'll be doing all the PYQs from 2002 to 2024. Till here we'll solve all the PYQs which have appeared in redox reactions. So previously we have completed the theoretical part of this chapter along with all the concept clearance, and now we'll implement those concepts to solve some PYQs, and specifically JEE Main 2020 2002 to 2024. So just allow me a sec. Now I think it's perfectly fine. So guys, I have a very big announcement for all those students who are right now preparing for their 2025 exam, JEE Main 2025. I have a big announcement here. The big announcement says that if you people are appearing for 2025 JEE Main first attempt, please give this test. This is your all India mock test that will not just give you a good quality set of questions, but also an idea how the question are gonna to appear, how are you gonna to appear in the examination, how to take the exam, and right after achieving some marks you can enroll with our predict your mock test. And this is your JEE Main rank predictor. You can put your rank over there, and you can find you can put your marks there, and you can find what rank do you exist. And this is what happens, what I can say, like session wise it happens. So we are the only providers over here, the Unacademy team. All thanks to Unacademy team, they are providing you individual percentile by shifts, and also you can get your exact idea where do you stand right now. Not just this, we have also one more important announcement here, everybody. So please scan this code, enroll with us, and then you will be getting a ranker reward program. We will pick up some of you very good students, and you just need to fill up your application detail forms over information over here, and then you will be given up with some rewards from Unacademy team. So that was a huge announcement for the day. And now let's come back to the first question of the day, and topic wise segregation I have done for this very beautiful chapter called as redox reaction. So let's start the first question, everybody, on oxidation number, oxidation state, the very first topic I taught you in redox reaction. There we go. JEE Main 2024, this question was asked in evening shift of 29th of January, first attempt. The oxidation number of iron in compound formed during brown ring test. Oh my god. Now believe me, everybody, these all questions are these are not just a single set of question, but instead these all questions are more or less like containing so many concepts in between them. So let us begin with the very first question we have. I am continuously monitoring your chats here, and I can get whatever the question you people are facing. Let me know. Okay, we have so many good. Okay, one is the correct answer, everybody. So many people have responded me one. Anyways, let me get you to the brown ring first of all. So guys, brown ring test is done for the nitrate ions, and in nitrate iron forms a complex containing water molecules and one nitrosyl ion. Now this nitrosyl ion, which is also called as nitrosyllium ion, has a oxidation state of +1. With the time you will come to know this is something that we study in like complex compounds also, and somewhere in P block also we study about the same. So we have NO, and then sulfate ion is here. So this is how it look like. If you separate them in ionic form, this will become 2 positive, and then sulfate 2 minus. Let us put the formula of oxidation state over here. What was the formula? X plus 5 times of 0. This nitrosyl you must take has a +1 charge, NO positive as an ion, so it's a positively charged ligand, and it's a complex compound we right now are facing, and we'll be having a +2. So X will be coming as 2 minus 1 is equals to +1. So those who have submitted +1 answer, they are absolutely right, everybody. Let's have a big round of applause for all the people who have solved this question. The +1 is the answer. Always keep this thing in your mind. It's a very huge important example, and this question have not been just asked in this 2024. It has been asked previously so many times. Now let us go to the next question. We have another question. In the reaction of potassium dichromate, potassium chloride and sulfuric acid, the oxidation state of the chromium in the product is what? So anyways, whatever the oxidizing agent might be there, like this is the oxidizing agent potassium dichromate, which is K2Cr2O7, and we all know what K2Cr2O7 in acidic condition, when we are given up with the concentrated sulfuric acid, this goes from what we are going to find is the reaction of potassium dichromate with potassium chloride and sulfuric acid. The oxidation state of chromium in the product is what? So guys, K2Cr2O7 goes to KCr3+, right? Isn't it? Now any submission of the answer, everybody? Okay, we'll bring that session also. Thank you, Shree's view. I got your point. We'll bring that session also. But as of now, we are preparing. We are trying to complete all our 11th syllabus along with the concept, along with the numerical solving. So that's why we are putting so much kind of efforts on this. Let's see. So in the reaction of potassium dichromate goes from K2Cr2O7 to Cr3+. The question is the oxidation state of the chromium in product side. So what do you think? What should be the correct answer? I think it's +3, because in acidic condition K2Cr2O7 goes to +3, right? Fine. Any more? We have a +6 answer that I don't understand. In the reaction of potassium dichromate, potassium chloride and sulfuric acid. So we have 3 things, and the oxidation state of chromium in the product. I personally find this shouldn't be correct. This should be +3. Correct? I told you once that in acidic conditions, dichromate ion Cr6 positive goes to Cr3 positive, right? Okay. Coming to the next question. Oh my God, we have plenty of good questions here. And this question was asked. This question was asked back in. Yeah, this question was asked in JEE Main 2023 6th of April morning shift. Question says that ammonium phosphomolybdate, the oxidation state of molybdenum. We only need to get the idea about the compound, and then we'll be getting it solved very easily. So guys, what should I say? Phosphomolybdate. So basically this is some ammonium phosphate. I am explaining you the simplest formula here, and some units of molybdenum oxide, which is MoO3. So this is the formula of this compound called as ammonium phosphate and molybdate. So this is what we call as ammonium phosphomolybdate. We are trying to find out the oxidation state of, more or less this is a double salt. Can't you see it's a double salt? So just remove this part and just simply observe MoO3. So if we observe MoO3, so x minus 6 is equals to 0, x comes up as +6. So this must be having a oxidation state of +6. The correct answer, let us check what was the correct answer given. +6, which is a good answer. I hope you all are doing it absolutely well, everybody. Hopefully you all are getting what I'm trying to explain over here. I can read the all chats over here. So whatever the answer you find, you please submit it, and we will basically work on that, and we'll give you the correct answer. Now, next question. We have another question on oxidation state. Topic wise PYQs we are covering, and we are going in a decreasing manner. Like the recent one has been asked very first. Recent one as in like 2024 questions will be asked first, then 23, then 22, 21. And believe me, a single question, whatever the question in PYQs has been asked till the date in a redox reaction, it is over here on your board with me. So guys, this is the best way of preparation. If you are following me, if you are following all the theoretical notes which I have already provided, then right now is the time to do the practice, and practicing these questions will get you up to the maximum level of the confidence. Let's come back to this question. Question simply says that the sum of oxidation state of metal in iron carbonyl. Okay, so iron carbonyl, guys, carbon monoxide, what kind of charge does carbon monoxide have? Zero charge. So this is having zero charge, iron will be having a zero oxidation state, VO2 positive. We know all about oxygen generally has a -2 oxidation state, so 1 time of is equals to +2, isn't it? The X comes up as +4. Then the last one we have WO3, tungsten oxide. See, it's very easy that we know that majority of the compound of oxygen forms oxide, which are the normal oxide in the oxidation state of -2. X comes up as +6. Now, can you add 0, 4 and 6? What should be your correct answer? I guess your answer should come up as 10. Let us see if the correct answer is 10 or not. 10 is absolutely fine. So anyways, we only need to get the idea about the compounds which you are having, and if we know the molecular formula, and then everything is absolutely fine. Let us come to the next question we have. So guys, this is all what we need. I gave you so many good questions on oxidation state of phosphorus. I gave you phosphoric acid, phosphorus acid, hypophosphoric acid, this, that, though. I have given you so many good examples, right? So we have the next question, or we have hypophosphoric acid, everybody. Okay, thank you for your suggestion, Shree's view. So guys, we have plenty of things here, but if we talk about the phosphoric acid and hypophosphoric, see, we have H3PO4 called as phosphoric acid. We have only thing, no? So this is called as phosphorus acid. We have one more substance called as with a single ionizable hydrogen. This is called as hypophosphorus acid. Hypophosphorus acid. Okay, but there is one more compound, and this is how it's represented. So one is there, another is there. It is directly connected with phosphorus, OH and OH. So guys, do you remember the part when I told you that whenever the oxidation state of any central metal atom comes lesser than the maximum possible, there is a possibility of having direct central atom bond. I told you this in my theoretical concept with giving you an example of H2S2O8, H2S2O6. Then I also had an example of H2S2O3, similar kind of example. This is also one of them. It is called as hypophosphoric acid. Guys, with the time you will be known about all these compounds and specifically their structures, and all of their structure and formulas we come to know in P block. So don't worry, those who are right now starting their 11th standard might be worried like how can we remember these complicated formula. Don't worry everybody, this is something that we are going to do whole year, and the limited number of compounds are there that will be known very soon. Okay, so now take the idea how this structure look like, and this is how the structure look like, and now you can easily predict out the oxidation state. Let us suppose if one phosphorus has been considered over here. So this on breakage gives no charge, this on breakage gives +2 charge, this on breakage gives another +1 and +1 charge. The oxidation state of phosphorus comes up as positive 4. So right now, after drawing the structure and this geometry, you can easily find out the oxidation state of any central atom you want. Let us see if the correct answer is positive 4 or not. It is absolutely right, everybody. That was a question came in JEE Main 2023, exactly 1 or 2 years back, couple of years back. Anyways, now next question, the sum of the oxidation states of bromine in bromic acid and perbromic acid. And believe me, everybody, I gave you so many good examples while we were doing the theoretical coverage of this chapter. Bromic acid, you know what is the meaning of bromic acid and perbromic acid? Perbromic acid is HBrO4, per iodic is HiO4, per halic acid is called as HXO4, and similarly halic acid is HBrO3. Now you want to calculate the oxidation state, please find it out. This will come up as positive 7, this will come up as positive 5, I guess so. And if you add them, I guess your answer should come up as 12. Is your answer 12? 12 is absolutely correct, everybody. So like more important part over here rather than calculation of the oxidation state is knowing the structures of the all compounds which we are getting, okay, knowing their formula, knowing their structure, and this is very much helpful for all of us. Anyways, we got our answer as 12 over here in this question that was asked in JEE Main 2023. And the way we are going, believe me, everybody, the way we are going very fastly, this will be very much helpful to us covering all the questions from redox reaction. There we have the another question, everybody. Another question, everyone. We have a JEE Main 2021 question which was asked in 27 July morning shift. The question is simple, says that the oxidation state of phosphorus in H4P2O7, H2P2O5 and H4P2 whatever it is. We will simply apply the oxide formation. We will assume all the oxygen as oxide. Wherever we find that the oxidation state of phosphorus coming beyond 5, which is the maximum possible oxidation state, there we need to consider what kind of peroxide bonds are there. Until unless you can be very relaxed solving everything using your oxide thing. So do it. 4 plus 2x minus 14 is equals to 0. X comes up as 14 minus 4 by 5 is positive 5. Which is the already the highest oxidation state possible for phosphorus. H4E2O5. We have H4E2O5. And how do we calculate it? This is simply calculated as 4 plus we have 2x minus 10 equals to 0. X comes up as positive 3. And the another formula is 4 plus 2x minus 12 is equals to 0. Okay, this is the hypophosphoric acid just we did in like some of the previous example, and X comes up as 12 minus 4 is 8 by 2 is positive 4. Guys, can you see like 5, 3 and 4, none of the oxidation state is going beyond 5. If none of the oxidation state goes beyond 5, that means every oxidation state over here is absolutely correct. Wherever we have taken oxygen as an oxide ion to oxygen with 2 minus oxidation state, it is absolutely correct. It can change, it can be changed to peroxide or superoxide, and specifically peroxide only. And when it happens, it only happens in the cases where you will be getting your calculated oxidation state by considering oxygen as minus 2 and your maximum possible oxidation state, like it comes even beyond maximum possible oxidation state. Let's say in this question the answer would have come 6 or 7, which is not even possible because phosphorus has only 5 valence electron. So maximum possible oxidation state can be 5. If any oxidation state come beyond that, that means there is a definitely possibility of the existence of peroxide rather than only oxide. Next question, everybody. Okay, that is what we did now. 645, 645. Okay, man. 645 is not the correct answer. I think 534 is the correct answer. See, 6 is not even possible. 3 is the correct answer. So somewhere we can find some discriminaties, and this is what happens. Like only human beings are preparing this. Might have somebody taken it as an wrong answer picked up. Okay, coming to the next question, we have identify the process with which change in the oxidation state is 5. Where can you find change in oxidation state as 5? Okay, let us come over here. We have dichromate ion with positive 6 with positive 3 over here. This is happening in acidic medium. We already have covered one question out of it. Now if you want to take about the example of what is the change in oxidation state, the delta of oxidation state of chromium is coming up as positive of 3. Now here it is positive 7, here positive 2. Delta of oxidation state will be coming up as 7 minus 2 is equal to positive 5. So guys, that is what it was asked. In which process can you find a change in oxidation state as 5? Yes sir, it is permanganate ion in acidic condition. You can find the change in oxidation state as 5. Or change in oxidation state is also called as N factor. So N factor of KMnO4 will become 5. Correct everybody. I think JEE 2026 King, you are mentioning the concept very well, that we right now are preparing every one of you for upcoming exam of 2026, not 2025. And even if people are watching this video for 2025, this is also beneficial for all of them, because you all know that what is the importance of PYQs at this peak time, and where we are having our exam just right after 1 week. So you can also take the benefit. And please everybody, those who are preparing for 2026, take these lectures very seriously. Believe me, these lectures are going to change your life. These lectures are going to give you the lifetime confidence on chemistry. And specifically for PYQs which you are doing, JEE Main category will be highly satisfactory for you, and you will be getting a level of boost confidence over here. Okay, let us come to the next question over here. We have another question, that oxidation states of nitrogen in nitric oxide, nitrogen dioxide, dinitrogen oxide and nitrate ion. What will be it? I know the oxidation state. Then oxygen will be taken as an oxide ion. Then nitrogen becomes positive 2, positive 4, positive 1 and here positive 5. See, these are some sort of very simple examples that we have covered already. So I didn't find any of the difficulty. Is it not visible clearly, everybody? Is it not visible clearly? Some of the part is like, okay, let me. Now this is absolutely clear, and everything seems right now in the frame. Every option, every single question, everything. You know what, this question was asked in JEE Main 2021 online exam, 18th March evening shift. Not even required. We know the correct answer. Nitrate will be at the top with the highest, and then nitrogen dioxide, then nitric oxide, then nitrous oxide. I guess the correct answer should be D. Correct? I personally found that this entire chapter is an easy chapter, and this chapter somewhere it involves a lot of concepts which are mixed from other chapters also, just like the identification of the chemical formula of the compound or identification of the structure of the compound. That is what somewhere it comes meanwhile. But honestly, this chapter particularly or typically is very easy, and we have solved so many questions till now. But you might have seen me not taking even more than 10 seconds to do the question, and that kind of confidence I want in every one of my student, that yes sir, redox reaction is something which is a bonus to us, which is a very beneficial chapter to us. Now let's come to the next question. We have dichromate ion is treated with a base and oxidation state of chromium. And so guys, this is something that I want to tell you. This is how it works. And in D block, okay, there is a chapter called as D and F block, where we understand the dichromate in very detail, preparation of this potassium dichromate as an oxidizing agent. Anyways, you always remember that this is Cr2O7 2-. This is called as dichromate ion, and if it is subjected to basic medium, then it gets converted to chromate ion, which is Cr2. What is it? O7. What is it? CrO4 2-. CrO4 2- is called as, this is called as dichromate ion, and this is called as chromate ion. So chromate ion, when it is subjected in acidic condition, chromate ion when it is subjected in acidic condition, it gives you dichromate ion. And similarly, a dichromate ion in basic conditions gives you what? Chromate ion. Now, what is the question has been asked? The oxidation state of chromium in the product form. Now, can you find it? I know that this is positive 6 and this will be X I don't think any oxidation state is changing here. Can I find the correct answer here? 6 is the correct answer. I think we did it correctly. X minus 8 is equals to minus 2. X is equals to 8 minus 2, that is positive 6. The oxidation state is the same. And that is why you remember one day I told you about this this part of the reaction, that whenever dichromate ion is given K2Cr2O72 minus as an oxidizing agent, so if we are having acidic condition, so in that way it goes to Cr3 plus, wherein factor can be found up as change in oxidation state into number of atoms present in this molecule. And if it is in basic condition, then I told you no oxidizing, there is no oxidizing action, no reaction happens like that. So this is something which we already have covered and probably you know about it. I think now everything is looking very clearly in the frame. Guys, keep on texting me, not a problem. Keep on chatting with me. This complete doubt section or this complete comment section is open for everybody. Whoever is watching it and whoever faces any kind of doubt till now over here and in any kind of question, do ask me very freely. Feel very free to respond to me on the questions. I literally don't think this entire lecture will gonna to take more than 2 hours, because the way and by the speed which we are going, I don't think this would take another 1 or 2 hours or beyond that. This is a very easy chapter, I told you once. Now we have everybody the next question for us. The very next question over here is with us. The question is simple and says that out of K2Cr2O7, KMnO4 and K2FeO4, the respectively XYZ are the oxidation states of this central atom or transition metal atom. Sum of XYZ will be what? So we are very much comfortable doing these questions, because this is like, okay, 2 plus 2x minus 14 equals to 0. X comes up as positive 6. We know the oxidation state of chromium here. Now KMnO4, we also have known about the oxidation state of manganese in potassium permanganate. 1 plus x minus 8 is equals to 0. X comes up as positive 7. We have another formula, that is K2FeO4. And in K2FeO4, 2 plus x minus 8 is equals to 0. X comes up as positive 6. These are some set of oxidation states possessed by given substances: positive 6, positive 7 and positive 6. Now can you count them and tell me the correct answer? 6 plus 6 is 12 plus 17 are 19. I guess 19 is the correct answer. It is very weird, but 19 might be the correct answer. 19 is correct, everybody. Very easy question, see. So the way I am like solving these questions, I want everybody, every student of mine to solve the question in the same confidence, because this chapter, as I told you, is very easy chapter, and not just an easy chapter, this is a very scoring chapter also, because if questions appear easy from this chapter and we have the idea how to get to these questions, then yes, we can definitely score more in our exam. There we have the another question asked in JEE Main 2020 online exam, 9th of January morning slot. Question is simple and says that the compound that cannot both act as an oxidizing as well as reducing agent. So okay, always keep this thing in your mind. Anything that can work as both oxidizing and reducing agent must have what? An intermediate oxidation state. Now what is the meaning of some intermediate oxidation state, sir? Guys, the meaning of intermediate oxidation state is something that has highest oxidation state, something that has highest oxidation state. Let us take in your mind KMnO4. Manganese with positive 7 is the highest oxidation state possible for manganese. It has only one possibility. Positive 7 to it can go to reduction in the oxidation state. Something which goes in reduction in oxidation state undergoes reduction, and something undergoes reduction is called as an oxidizing agent. So this species KMnO4 or MnO4 minus can only behave as an oxidizing agent. Getting me? But what about something which is an intermediate? Intermediate as in, like sulfur has an highest oxidation state of positive 6, lowest could be -2, and I am having sulfur in, let's say, 0 oxidation state. I can go to either of the direction, either from S and 0 state to S2 minus, where it is working as an oxidizing agent undergoing reduction. And then another example could be sulfur is going to the higher oxidation state of positive 4 or positive 6, where oxidation is happening and sulfur itself is behaving like a reducing agent. So something it should be in intermediate oxidation state. Now let us see whether it is in intermediate oxidation state or not. S3PO4, it has a positive 5, it has positive 3, it has a positive negative of 1, and then it has a positive 3. So guys, nitrogen has minimum of -3, highest of positive 5. It is an intermediate. Oxygen negative -2 can go, 0 can go. It is an intermediate. Sulfur has maximum positive 6, minimum of -2. It is an intermediate. But maximum of phosphorus has positive 5 oxidation state. And if it is, so this can only behave as an oxidizing agent. This can undergo reduction, and yes, this can only behave as only as oxidizing agent. The correct answer should be A, oxidizing agent. A is the correct answer. I literally don't think these questions are that worthy or that much time they require. Just look at the question and just click on the answer, and that is how we have to build ourselves. Coming to the next question of the day, everybody, we have a question saying that oxidation state of potassium in K2O, K2O2 and KO2. Believe me guys, this is most easy question of the day you are facing. Potassium, this is your potassium oxide. Potassium oxide. This is potassium peroxide. And then we have potassium superoxide. But believe me, there might be having different oxidation states with oxygen. So let's say K2O is there, positive 1 is here, oxygen will be having a -2. Then in K2O2, potassium, which is alkali metal, they always have positive 1 oxidation state in their combined form, but oxygen will be having a -1 oxidation state. Similarly, KO2, potassium will be having a positive 1, and this has a -1/2 called as superoxide ion. So what kind of oxidation states are we getting for potassium? In each 3 compound, we have positive 1, positive 1, positive 1. B should be the correct answer. Now let's see who has submitted me the correct answer. Okay, it's Swayam J King. Seems nobody has submitted the correct answer. Anyways, we will do it with the time, not a problem as of now. Moving forward with the another question, B was the correct answer, everybody. I hope that you are getting the concept right now very easily and very straightforwardly. We have another question, correct oxidation states of nitrogen compounds. This is called as nitric oxide, positive 2 oxidation state. N2 is called as nitrous oxide, laughing gas, and nitrogen has an oxidation state of positive 1 over here. Nitrogen dioxide has a positive 4, just like CO2, just like NO2. And N2O3, it has like 2x minus x equals to 0, x comes up as positive 3. Now, can you arrange them in an order where you can find the maximum, like lowest to highest? So lowest is in N2O and highest will be in NO2. I guess C is the correct answer. I guess C is the correct answer. Don't you think C? C is the perfect answer. So guys, questions are not that difficult. Believe me or not, these questions are highly easy if you apply the same concept which I am doing, and if you follow me strictly and religiously and very dedicatedly. And I also have given you a path like how we are proceeding for your preparation of 2026. Those students are typically following us, they will be getting a lot of confidence till the end of this year. Guys, believe me that when we started these sessions, we had this very clear in our mind that we are gonna to give you a proper theory session that might be taking 3 hours, 4 hours, 5 to 6 hours, but we will be teaching you up to your advanced level with the clarification of each and every concept. And right after finishing the this conceptual part or this theoretical part, we'll be conducting one session where we will be dealing only with the PYQs, and I come up here with the topic wise PYQ, which gives you an absolute idea that on this topic these kind of formula will be used and this kind of questions come. So until or unless you are pretty much able to solve the question, there is no use of learning from the formula or just only going for the theoretical part, because believe me, this is physical chemistry, and physical chemistry requires an application rather than just rote learning of the all formula. We must know how to apply those formula. What kind of application can we get out of this formula? Now come back to the next question. We have the correct order of oxidation state of nitrogen. This is already covered, man. First part of this chapter has been completed from my side and from your side as well. This part was oxidation state. The next part, next topic out of this chapter is oxidizing and reducing agents. You all know about agent. What agent do? Agent book a ticket for us. Similarly, oxidizing and reducing agent do the oxidation reduction of the front species, not by themselves. They do an opposite work of themselves. How? Let's see some example and then we'll come to know. We have a question. We have a great question over here, everybody. The number of ions from following that are expected to behave as oxidizing agent. Which of them can behave as an oxidizing agent? Can you find it? So guys, only behave as oxidizing agent means something which is present in its highest oxidation state that can only undergo reduction. So I guess SN4 plus highest oxidation state it is having, because it belongs to carbon family. Carbon, silicon, germanium, tin, lead all have positive 4 oxidation state as maximum. We also have thallium 3 positive, highest oxidation state possibly. Lead 4 plus, highest oxidation state. Right? Can I see the correct answer? Okay, answer is 2 actually. A number of ions that are expected to behave as oxidizing agent is, I don't know what's the problem over here with okay, thallium is stable in +3, I guess. Probably these two will be working, and this is a concept we called as inert pair effect. I'm still not sure like why we are not considering thallium. Indian gallium, thallium should also be there, yeah. So thallium 3 positive goes to thallium 1 positive. So SN4 positive, PB4 positive, TL3 positive. These all will go to their lesser oxidation state by reduction, and if they are undergoing reduction, then they must be working as an oxidizing agent. My answer should be 3 rather than going for 2. Rest of them can work as an oxidizing as well as reducing also. So only typically talking about the oxidizing agent, I will pick up these answers. 3 answers will I'll pick, and we'll come to know about it in P block somewhere. Next is this question, everybody. Now let us check out this question. Thiosulfate reacts differently with iodine and bromine. So thiosulfate is actually a reducing agent. Thiosulfate is what? Is a reducing agent. It reduces the front species. And if it is a reducing agent, definitely a bromine and iodine will be working as an oxidizing agent. It will be oxidizing to sodium thiosulfate, Na2H2O3 to Na2H4O6, and similarly with NaSO4 also. So something that comes in my mind is, let us see if iodine is working over here. This is having a positive 2 oxidation state, this is having a positive 2.5 oxidation state. And so let's say the N factor, if we talk about N factor of H2O3 in reaction number 1 is how much? Reaction number 1. This is, I guess, 2 times of 0.5. This is 1. So guys, do this calculation that number of moles of H2O3 2 minus you are oxidizing into its N factor 1 is equals to number of moles of iodine you are taking in its N factor. Its N factor is how much? Its N factor is actually 2. So the number of moles of H2O3 you oxidize over here, let us suppose this is 1 mole. If this is a 1 mole, then only 2 moles, 1 mole of iodine can oxidize how many moles of thiosulfate? 2 moles. Now we'll bring out the same reaction and we'll examine the next one. We have sulfur over here in oxidation state of +2, and sulfur has reached to +6 oxidation state. Bromine is doing the same, Br2 to Br minus. If you apply this formula, that N factor of S2O4, S2O3 2 minus, how much would it come? Change is from 2 to +6, 4, and 4 into 2 is 8. So guys, here the number of moles of S2O3 2 minus into its N factor 8 will be equals to the number of moles of I2 Br2 into its N factor is 2. So guys, the number of moles of Br2 number of moles of S2O3 2 minus which are like oxidized here are how many? Okay, let me just recheck it. Number of thiosulfate molecules are 2 moles there. So which of them you find is a better oxidizing agent? Somebody who's sending 2 to 2.5, or somebody who's sending it from positive 2 to 6? This is a debatable question, by the way. But anyways, we have our either way. In first question, we found that 1 mole of an iodine can oxidize 2 moles of thiosulfates. And in the next thing, we can find that 1 mole of S2O, 1 mole of Br2 get oxidized. Man, 1/4 only, I guess so. The correct answer is bromine is a stronger oxidizing agent than Br2. So actually, this is not about like how many moles something is, how many moles of some oxidizing agents are needed. It's more about like from where to where something has gone. So something is going from positive to positive 4, positive 2 to positive 6, and something from going from positive to positive 5. So something is going in higher oxidation state with the help of bromine and with the help of iodine. So bromine is said to be the stronger oxidizing agent here than iodine. This is what the question is asking. But anyways, we'll keep this question in our mind and we'll come back to it, and we'll give more basically clarity on this question further. Now let us take this question in our mind and let's move to the next question. Elsewhere we'll be, do you know what? We'll be unnecessarily wasting our time. A question is here that MnO2 and H2SO4 are added to a salt A and a greenish yellow gas is observed. Now what should be the correct salt? So guys, that greenish yellow gas is actually your Cl2 gas. So we have to take this thing in our mind that where can we get the Cl2 gas, and here MnO2 might be working as oxidizing agent. So guys, the reaction might be happening in somewhere like this: MnO2 plus NH4 Cl, and in acidic condition this might be converting down into manganese sulfate, MnSO4 plus Cl2 plus ammonium sulfate. This is how this reaction works. So what we are getting is one compound, that Cl2 gas, and this is what it is working as an oxidizing agent, and chloride from -1 going to 0. So this is what it is happening, the oxidation. Got it, everyone? The correct answer should be A. Rest other, like iodine could be a purplish vapor and purple colored solid particles, and then KNO3 it's already in highest oxidation state, cannot be further oxidized, and then NaBr, Br2 is a red color liquid. The only greenish color gas that you can get is the chlorine gas, and that's how we got the idea. And let us see if the answer is correct. Yes, it is absolutely correct. So that's what a belief that I want every one of you, that even if you have a partial idea about the question, then also you can solve the question and you can give the correct answer out of it. In previous question, it was not even required to do the calculation or doing the complete writing of the equation. Rather than you can easily pick what gas color it's look like and which gas can have this much color, greenish yellow. It's chlorine. Bromine is a red color liquid. It's a kind of blood red color, dark red color. And we have a iodine with purplish color. So this is how we have to find out. Next question, everybody. It's a typically factual question. Typical factual question that in permanganate. So guys, iodine in, it's a very different thing that we experience here. That if the reaction happens in acidic medium, the reaction goes to I2 and Mn goes to positive 2. The individual part is absolutely clear that iodine is undergoing what? Oxidation. And permanganate ion undergoes what? Reduction. But the now what example I'll give you is I minus with MnO4. Same thing is happening, but now it's happening in basic conditions, OH minus. In basic condition, what happens? Iodine comes to IO 3 minus, called as iodate ion, plus manganese will be converted into basic medium in Mn. MnO2, or could be Mn MnO4 2 minus manganate ion. Anyways, the similar thing you can observe that iodine is undergoing oxidation here in iodate ion, and permanganate ion is undergoing what? Reduction. Note it down, everybody. It's a very important reaction, I'm telling you. Correct answer should be IO3 minus B. The question came very straightforward, not even asking the concept behind it, simply asking where are you leading with iodine in this particular concept or the reaction. Clear, everybody? I hope this part is absolutely clear to all of you. And even if not, the comment section is absolutely free for all of you. Those who are watching this video lively, they can comment me in the live chats. Those who will be watching this video right after some time or might be watching this video a few days later, they may comment me in the comment section itself. I have always given the priority to the comments of students or the doubts of students. I'll resolve it and will respond to you back over there in the comment section itself. Next question. Which of the following cannot function as an oxidizing agent? What do you think? Cannot work as an oxidizing agent. Which cannot work? So oxidizing agent is what? Which may undergo reduction? May no. Always goes. So it goes reduction. It undergoes reduction. So where can you find the reduction? Something which is present in the highest oxidation state or higher oxidation state relatively. This is in positive 6. This is in positive 7. This is in minus 3. This is in positive. It's BRO3, so it is positive 5. Now this is something which is present in its lowest possible oxidation state. And if something is lower possible, it can only undergo oxidation. If something can only undergo oxidation, can never undergo reduction, and it will never work as an oxidizing agent. So C is the correct answer. So Sagar diya. Now we'll come to the next question from here. The very next question is simple and says that we have two statements. We got to find out which one of them is correct, which one is not. Sodium hydride, which is NaH, can be used as an oxidizing agent? No, it's a reducing agent, by the way. Okay, let me see. Sodium hydride NaH. So guys, Na is like this, H minus, Na plus. So let us suppose this reaction goes in with the formation of hydrogen. Are you understanding this process? This process is what? Loss of electron. This is oxidation. If something undergoes oxidation, the species might be recommended as a reducing agent. This is a reducing agent we are having. So I guess the first statement might be false. Not so confident about it, but we'll see the another statement also. The lone pair of electrons, nitrogen pyridine, makes it basic. Absolutely correct, because this is how the structure of pyridine look alike. And it's an aromatic compound, and this can be lost and makes it a Lewis base. Now what is a Lewis base? That you will understand very soon. So correct answer should be, this is a true statement and one is false. One is false, two is true. A is the correct answer. Let's see if A is correct or not. A is absolutely correct, everybody. Let's enjoy this. So it seems like this is a very easy part of this chapter, and it doesn't seem like that this chapter or this solution what we are right now doing will go a bit longer. I think we can cover all these questions in just 2 hours. So my target of the day will be in order to cover it very soon, as soon as possible, and I would like you people to participate with me as well, so that we can finish it on time. Redox reaction among the following is, which of the following you find is a redox reaction? Reaction of H2SO4 NaOH? No, acid base reactions are never redox. Why is it so? Because sir, 2 times of NaOH with 1 H2SO4 produces Na2SO4 plus 2 H2O. Now you can find everything over here as a fixed oxidation state, and it's not even changing. +1, -2, +1. Sulfur has +6, this is a +1, this is a -2, this is a +1, this is a +6, this is a -2, this is a +1 and -2. Now can you find any species which is undergoing change in oxidation state? No. Then this can't be called as redox. It's a non-redox reaction. It's a non-redox reaction. Let us come to the another question, another part, formation of ozone. So this is also non-redox, like O2, 3O2 produces 2O3. Oxidation states are 0, 0. So this is non-redox. Combination of dinitrogen N2 plus dioxygen O2, and maybe like they are producing nitric oxide, and there we can find it that something from the oxidation state of 0 and 0 to going +2 and -2. So this is oxidation from N2 point of view, and it's reduction in oxide point of view, oxygen point of view. Okay, reduction. So tell me the correct answer, everybody. C. Absolutely. Find out. Next is, in the reaction of oxalate with permanganate ion, oxalate is H2C2O4, like C2O4 2- ion. Anyways, we should write it and then we should calculate it. We are having this question that C2O4 2- plus in the reaction of oxalate ion with permanganate ion, permanganate is MnO4, and we are having this in acidic condition. So we know that this will be converted to CO2, manganese will be converted to Mn2+. The beauty of this concept, redox reaction and equivalence concept, is we do not require to balance the chemical reaction. Without balancing, we can find out how many molecules of CO2 will be formed. So the number of electrons involved in producing one molecule of CO2. If you have one molecule of CO2, so how we are doing? So see, like that we have to do. Electrons involved, okay. Okay, we'll see. There are like multiple ways I can do this question, but I like to give you the perfect and shortest way. Okay, do it using your half reaction method. So you write it like this: C2O4 2 minus, and oxidation is happening here now. So this will produce 2 CO2 in order to balance the carbon, and we also have to write the number of electrons involved. Something is going from positive 3 to positive 4. The number of electrons it has lost is 1 in one carbon atom. By 2 it will be losing 2 electrons. Similar reaction could be permanganate ion over here with the positive 7 oxidation state will accept some set of electrons. How many? And then it will give you Mn2 positive. So how many electrons does it accept? 5 electron, right? But this is not balanced in electronic point of view, so we will multiply the above reaction with 5 and this reaction with 2, and then we will get total 10 electrons are now involved with 5 Cr2O, not Cr, 5 C2 O4 2 minus plus 2 MnO4 minus gives you 10 CO plus so guys, can you see what we can see from this reaction? What can we observe from this reaction? That how many molecules of CO2 are formed? So just simply apply the unitary method, that since 10 moles of CO2 obtained, 1 mole of CO2 obtained by 10 moles of electrons transfer, right? Similarly, if 1 mole of CO2 is there, will be produced by 1 mole of electron. So I think the correct answer should come up as C. See, I had multiple options in my mind. The moment I started this question, I thought like it might be having D as an answer, 5, but everything what I did is just follow this, and I followed it until unless I got my answer. And then one day at one point of time I got the perfect answer with a pretty good explanation before this question. Right everyone, I hope this is absolutely clear to all of you, and even if you face any doubt, do let me know. I'm right now available over here, not a problem. You may ask me anything you want. We have the next question. Which of the following reaction is an example of redox, which you can find out as a redox? So redox reactions involve change in oxidation state, so that reduction and oxidation may occur. If somewhere you find there is no oxidation reduction occurring or no change in oxidation state occurring, that means it's non-redox reaction. Take an example: xenon is positive 6, fluorine is minus 1. Xenon is positive 6, fluorine is minus 1. This is non-redox. Non-redox. Xenon is positive 6. Xenon is positive 6. Fluorine is in minus 1. Fluorine is in minus 1. This is non-redox. Xenon is positive 4. Oxygen is positive 1. Oxygen is 0. Xenon is positive 6. This is happening oxidation. गद्दे न दूर हो जाए न जाए ओ सागर जी C is the correct answer. Check about this example also. It's positive 2 and is in oxidation state, and it is in positive 5. Fluorine is in minus 1. Fluorine is minus 1. So this is also non-redox. Wherever there is no change in oxidation state, there is no oxidation, there is no reduction. Such kind of reactions are non-redox reactions. A redox reaction is something where oxidation and reduction happen simultaneously with the same, at the same extent. C is correct. Now let's check out the next reaction, everybody. We have the next question and some set of reactions here, and I have to find out, we all have to find out where we cannot find H2O2 as a reducing agent, where you can't find out H2O2 as a reducing agent. So any suggestions? There were we. There were. This is the question. Okay, so which of the following H2O2 is acting as a reducing agent? Reducing agent, okay. So something which works as a reducing agent itself must undergo oxidation. It must undergo self-oxidation. So guys, please find out where can you find where electrons have been lost. And what do you see? Okay, see -2 electron, this is good. Where else can we find minus? So it's 2 and 4, I guess, not even required with so much. Wherever you are deducting the number of electrons, there or definitely it will be going under reduction. And also you must see reducing agent, like this is in -1 oxidation state, and then it is reached to 0. And now something has undergone oxidation, then definitely this reaction, which is where it is going in oxidation, it might be working as a reducing agent. Like we have to apply the concept. Likewise. Then next question is, which of the following reaction depicts the oxidizing behavior of H2SO4? Where can you find sulfuric acid is working as an oxidizing agent? So NaCl blah blah blah. It is in +6 oxidation state. There also it is in +6 oxidation state. This reaction is non-redox. Wherever there is non-redox reaction, no oxidizing and no reducing behavior will be seen. Somewhere where you can find it is undergoing reduction, there only you can find it. SO2Cl2 is also +6. Non-redox. Non-redox. +6, +4. Yes, sir. Here we can see reduction is happening. If something is undergoing reduction, it will work as an oxidizing agent. C is correct answer. Blah, blah, blah. So can you find the correct answer, everybody? Which of the following is a redox reaction? So this is your NaCl. Just check out their oxidation state, okay? Not a problem. Positive Y. A double displacement reaction only, guys. So -1, -1, and nothing is. It's a non-redox. And CaC2O4. This is another non-redox. Why? Because these two are simply, or not just these two, these even three are simply double displacement reactions. And I told you once while I was teaching you the theoretical session that all the double displacement reactions are non-redox in nature, and all the displacement reactions are always redox in nature. So this is non-redox in nature. This is simple double distillation reaction. Okay. This is another non-redox. मैं हूँ सागर, तुम हो किनारा, सितारों की महफिल, गूंजेगा ज़माना, होठों पे आया दिल का फसाना रे, दिल ने दिल को पुकारा, there's nothing happening. But in the last option, what do I see? What do I see? Zinc is in zero oxidation state, zinc is in positive oxidation state, silver is in positive oxidation state. Now it is in zero oxidation state. So zinc from 0 to positive 2 is an oxidation process, and silver from positive 1 going to 0 is a reduction process. So this is a redox reaction. Correct answer should be D. मंजिल पर तुम्हारा. So guys, this is an opportunity for all of you, that if you are preparing for JEE Main 2025 and you want to examine yourself for the exact similar simulation, the best test you want to give through all over India, and you also want to get your all India rank prediction, just go. The link is given in the description itself. It's our AIMT which is going to happen on 19th of January. So this weekend only you can give your exam, right before your main exams is about to start the next week, and then you can also predict your rank just by only submitting your marks, and shift wise rank you will be getting, shift wise percentile you will get. Also, very important announcement for all of you, just scan this QR, fill some basic information related to your application form, and Unacademy can reward you the time of your JEE main results. So if you will score well JEE main result in your JEE main, so Unacademy will provide you some benefits you and some reward, which is our ranker reward program. So do scan it. Now next question is, next topic we have come to is type of redox reaction. So the sequence that we literally followed in our theoretical session, in our conceptual session, same sequence we are following right now also, and now we have jumped to the type of redox reaction. Let's see the first question of the day out of type of reaction. This question couldn't, like, it was a huge question and some options were given, but I couldn't come up with all of the things together, so I have already given you the options and we'll match them and we'll get to the correct answer. This reaction where two simple substances are added together forming a new substance called as addition reaction or combination. This will become fourth. This is a decomposition, so it will simply go to first. This is displacement reaction, and specifically this reaction is a what you find is, it's a metal displacement or what? We can't say about it because sodium is displacing hydrogen here. What do you see? Displacement is fine. And here can you find that nitrogen from positive 4 oxidation state is undergoing oxidation as well, positive 5 and positive 3 also. So oxidation and reduction both are working. This is a disproportionation, a reaction in which same element from the same compound or ion undergoes oxidation and reduction simultaneously, is called as disproportionation reaction. DP reaction, remember DP reactions. Anyways, let's come to the next question. We have total number of species from the one which can disproportionate. So anything that can disproportionate must have what? An intermediate oxidation state. Something which is in intermediate oxidation state can undergo oxidation also and reduction also. So H2O2, oxygen with -1 oxidation state, ClO3, positive 5 oxidation state, phosphorus 0, chlorine 0, silver 0, copper +1, fluorine 0, NO2, nitrogen dioxide positive 4, and potassium with +1. So potassium cannot go. ClO3 can go to +7 also, 0 also. Cl2 can go to plus also, minus also. Silver can go only in positive oxidation state, not in negative. Copper +1 can go to 0 and +2 also. Fluorine can never go. So I think the remaining one should be the correct answer, and the rest we'll check on. H2O2, ClO3, phosphorus, chlorine, copper, and nitrogen dioxide. 6 is the correct answer. Have we submitted 6? 1, 2, 3, 4, 5, 6. Absolutely everyone. Round of applause for me. It's me only who's solving these questions for you all, and you people are now just watching it, not solving the problems and not submitting me the correct answers, and I am not enjoying this part, or I have been surrounded by a lot of wires and some Next is, which of the following reactions are disproportionation reaction? Disproportionation reactions are very well known to you. A reaction in which a single element undergoes oxidation as well as reduction from single molecule or ion. It is called as disproportionation reaction. So what do we call? Zero oxidation, sorry, it is in +1 oxidation state, goes to +2 and 0, disproportionation. MnO4 2 minus +6, MnO4 minus +7, and MnO2 +4, disproportionation. K MnO4 +7, something is already in highest oxidation state, cannot undergo further oxidation. This is non-redox reaction. This is +6, this is +4, but this is no disproportionation reaction, no DP reaction. Then fourth one, the MnO4 minus, again +7, this is +2, this is +4, and this might be a symproportionation reaction but not disproportionation. Correct. So this is also incorrect. So correct answer should be A and B. So where can you find A and B? Option number A. दिल ने दिल को पुकारा, ओ मैं आया मिलने दोबारा, मंजिल प्यार तुम्हारा, मैं हूँ सागर तुम हो किनारा. Okay, now I'll take you to the next question of the day, everybody. We have A as the correct answer here. Of course, if we are submitting some answer, it will be correct only. It's a very easy, basically this chapter is highly easy. We have a question that which of the following options are correct for this reaction. What is this reaction, guys? We all can see that gold, this is called a cyanide process of extraction of gold that you will be getting in 12th standard, one of the biggest chapter called as metallurgy, not a part of JEE Main these days, but yes, we'll cover it someday from advanced point of view. So this is in positive, what is it, +1 oxidation state here. This is in 0 oxidation state. This is 0 now, and this is in +2 oxidation state. So can you find the difference? Zinc has displaced gold here. So is this reaction a redox? So I think this is a redox reaction. Yes. Is this a displacement? Yes. Is it a decomposition? No. It's a combination? No. So I think 2 points are correct. Can you tell me the correct answer? Choose the correct answer from the options given below. So where are the given below options? Okay, option given below aren't there. The correct answer should be A and B are correct. So it's not a multiple choice question. Actually, some options were given down, but because that was not too much space we had, we completed this question up to here only. So guys, those whoever are watching this lecture, do like the session, everybody. The way we are coming up and the way we are bringing this much energy for you, we want you people to support us We'll create a huge channel here. We'll be dedicatedly doing these sessions for all of you people who wanted us to teach in English, and that was the day we decided to come up with. Today we are following the same. We want you people to show more dedication towards us. Like the session, subscribe us, share within your community, share to those people who want to study, and in the same language we are providing the session in English, which is. Next question comes up is, which of the following is not an example of disproportionation? So you all know what is disproportionation reaction, in which same element will undergo oxidation reduction from same species. Like take an example, -1 is going to -2 means reduction, and O2 0 means oxidation. This process is actually reduction, and this process is actually oxidation. Similarly, positive for oxidation state going to +5 and +2, and not HNO2 is +3, and this is also disproportionation reaction. This was also disproportionation reaction. +7, it can only undergo reduction, cannot undergo oxidation. So this is no disproportionation. So C is the correct answer, and rest this is also disproportionation. +6, +7, +4, another DP reaction. Correct answer is C. Next is, which one of the following is an example of disproportionation reaction? Okay, now it has been asked. Similar questions have been asked previously, I see, and that previous question also came in 2022. This is also from 2022. Let us see. This is in +6 oxidation state going to +7, and this is +4 oxidation state. This is an example of disproportionation reaction. Which of the following? This is correct only, right? The first option is correct. This is +7, and +7 cannot undergo further oxidation, so this is definitely be non-disproportionation reaction. This is +4, so no DP. This is -1, this is +7, and there it is going +2, and this is 0, but it is again might be a redox reaction, definitely a redox reaction, but not disproportionation. It's +7, again +7 cannot further oxidized. This is +2, this is +4, and this is +6, but again this is no disproportionation. Not a single element is undergoing oxidation as well as reduction. A is the correct answer. And now let's see whether we are right or wrong. So I probably think, okay, A is the perfect answer. Everybody, we have submitted the most correct answer over here. Hopefully you are enjoying the session. Hopefully you all are enjoying the session now. Another question, similar question. I've been bored of these questions now. Pick a disproportionation reaction. Disproportionation reaction, we all know, man. Oh man, zoop. This is no DP. This is +7 and going to +6, and then no. What's it? KMNO4, MNO2, KMNO4. And I have no idea on this, but this is not. Somewhere it should be K2, MNO4. Anyways, but this is, I can see, -1 is going to 0, and no. This is not disproportionation, this is intramolecular redox reaction. This is intramolecular redox reaction. So, what I should do up now? Because bromine, copper is in the +1 oxidation state, copper goes to +2 oxidation state, copper goes to 0. Yes, guys, yes! This is the one we were looking for. This is an oxidation and reduction simultaneously. The correct answer should be Z. Y. C is the correct answer. Then we have equivalent concept, and from this equivalent concept we should take a break, and we'll join you shortly right after this small break. It's a breakfast break we have. Then we have balancing of redox, then redox titrations, and that's it. So that's it, guys. That was a good break, huge break we had. That was some breakfast break we had. Hopefully you all have eaten something well. From onwards it will literally take another 1 hour or half an hour only, but we will try to finish the complete remaining number of topics. Yeah, so number of topics which are remaining right now apart from your till now is equivalence concept, rebalancing of redox reaction, and redox titration, which is an application of the redox reactions. Let's start it from the very first question from equivalence concept that was appeared in JEE Main 2022 online exam. The question is pretty simple and says that normality of H2SO4 in solution obtained by mixing 100 ml of H2SO4 and 50 ml of 0.1 molar NaOH will be what? This seems a very easy question to me, but I would like to do one thing. What we can do is simply we have to first add them, and H positive balances the OH minus, neutralizes OH minus. So let us take this reaction in such a way that there could be two ways to identify and to solve this question. One is to directly solve up with the number of equivalent. Another one could be solving with the moles also. So let us say if we are going to find out the equivalent, then how are you gonna to solve this question? Number of gram equivalent of H2SO4 will be how much? 100 ml multiplied by 0.1 molar multiplied by 2. What is this 2? 2 is the N factor, right guys? This comes up as 20 milli equivalent. Okay, these are milli equivalents of H2SO4. Then you can find out the number of gram equivalents of NaOH, the gram equivalent of NaOH, by simply doing the same, which is volume molarity into N factor is 1, and it comes up as 5 milli equivalents. So we all know that 1 gram equivalent of H2SO4 reacts with 1 gram equivalent of NaOH, and the number of remaining number of gram equivalent of NaOH left after this reaction will be 20 minus 5 is equals to 15 milligram equivalent. Okay, and volume final will be how much? Final volume will be after mixing these two solutions, which are aqueous solutions, 100 plus 50, so it will be like 150 becomes 150 ml. All set, all clear? Yes sir, why not? So now what you want to find out is the final molarity of the solution. How can you do it? Simply, so the normality, we have to find out the normality of H2SO4 will be number of gram equivalents left right after the final process, which is 15 milli equivalent divided by volume in this, so it is coming up as 1 by 10, yani 10 to the power minus 1, so it is like 1 into 10 to the power minus 1 normal. So guys, can you see the correct answer over here? I guess 1 should be the correct answer. What do you think? Okay, we'll check up. So 1 is the absolutely perfect answer, and I have already told you that whenever gram equivalence is there, it's the best way to sort out the questions and solve out the questions in gram equivalent itself, because it's the most easy way and a very adaptive way, and it always leads you to the giving correct answer of the question. And I always recommend you to solve questions using gram equivalent. We have another important question here based on the same concept of gram equivalent. Let's see what does this question say. First of all, question says that the neutralization occurs when 10 milliliter of 0.1 molar acid A is allowed to react with 0.05 molar 30 ml of a base MOH whole twice. Basicity of acid is known. You must know whenever the reaction occurs, the gram equivalent of acid become equals to gram equivalent of base when complete neutralization occurs. If it is not complete neutralization or something is taken in excess, then the remaining amount can also be calculated using gram equivalent that we have done in our previous question. Gram equivalent of acids are how much? 10 ml. multiplied by 0.1 molarity into its n factor must be equals to the one more base. We have 30 ml, 0.05 molarity multiplied by n factor is 2 because number of OH minus it can release is 2. N factor becomes 2, and that's what we have to find out the n factor for an acid. So guys, how much this n factor comes up? This is 2. You can cut out this like this. This is 2. This is 20. So 30 into 2 by 20. I guess the correct answer should be 3. Can we check the answer? If I am doing the question and I know the concepts and I am going in the correct direction, it's never possible that will lead you or will reach to the incorrect answer. Answer will always be right. What we have to do is proper determination is required. Whenever you study some particular theoretical session, make sure that you make a proper notes out of it. You have to formulate your notes in the sequence that in which we have taught you. You must remind every roadmap in your mind that first we studied this, then we came to this, we came to this. Wherever the important formulas are, that highlight them. Take every highlighted formula in your mind, and when you start solving the question, do apply them. But again, be very conscious while applying the concepts, because it's the major important part of entire physical chemistry, that if we can solve the question, if we can solve the numerical, then only we can say that yes sir, we have applied the concepts very well. Until unless you are solving the questions well, it's none of the theoretical sessions or none of the theoretical questions gonna to come in your exam. It's typical physical chemistry. That's the beauty of physical chemistry. Let's come to the next question, everybody. A similar kind of question, but here we can see it seems like an acid base kind of numerical to me. No, it's a redox kind of numerical here. 0.01 molar KMnO4 solution was added to 20 milliliter of 0.05 molar more salt solution, and through a burette. The initial reading was 50 ml. Burette is 0 and the blah 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 blah. Yeah. So okay, we'll solve it. Do one thing, everybody. Do one thing. So what is the Mohs salt, by the way? And the Mohs salt is NH4 whole twice SO4 dot Fe SO4 dot 6H2O. Most importantly, the oxygen over here is present in positive, sorry, iron is in positive too. So the reaction occurs in such a way that KMnO4 or permanganate ion reacts with iron 2 plus in acidic conditions, leading itself reduced to Mn2 positive and oxidizing iron to Fe3 positive. That's the typical chemical reaction we'll see here. Now using this reaction, we will try to find out what has been required, what formula need to apply. Just allow me a second. Oh my god, my So ultimately, at a point of time when the equivalence point come, at the rate equivalence point, what you will observe, everyone, we will observe that the gram equivalent of permanganate ion or KMnO4 solution must be equals to gram equivalent of iron 2 positive we are taking, or the Mohs salt, right? So it's 0.01 molar KMnO4 solution and added to 20 ml, and the volume of KMnO4 left in the burette after endpoint is, so that's what we have to find out. How much would it be left? So see, initially this is 50 ml. So first of all, we must know that how much volume is used. So that is what we can find out from here. So it is said that this is the volume that we are using into 0.01 molar, and N factors are pretty much known to us. That N factor of permanganate ion, see, positive 7 to positive 2, the N factor is 5, must be equals to gram equivalent of A2 positive. The N factor is pretty much known to us. Plus 2 to plus 3 is, N factor is 1, change in oxidation state is 1. Then volume used is 0.05 molar, N factor is 1. How much is volume of MnO4 minus used? Used is equals to how much, guys? So Uh, this is 0.01 cancelled up, 20 ml. So if it is 20 ml, then what is the volume of KMnO4 left in burette? Left in burette. Burette was initially having 50, then 20 is used. I guess 30 ml should be the correct answer. See, it's a beautiful question, by the way. And somebody, even if this question has been completed till here, the question was already completed, and if somebody has picked 20 ml as the answer, they will suffer here, because the correct answer is 30. You need to completely go through the question. You must understand the question pretty much well, and then you are supposed to put the correct answer. Unless you are giving the correct answer, you will be getting a negative 1 only rather than positive 4. Oh, that was a good question, by the way. Very good question we had. Now coming to the next question of the day, everyone, we have a question calling 100 milliliter of the solution. Okay, try this question by your own once. Yeah, guys, so did you try this question? Did you try this question? I gave enough of the time on this question. And since we were solving some of the question very repeatedly, and I found that the similar concept was used, so I gave this question particularly to you to solve it, and hopefully few of you have done it correctly also. Let us see what is this question saying. Question says that 100 milliliter of a solution was made by 1.43 gram sodium carbonate, and the normality of the solution is this, then value of x is what? So it's a very easy question, by the way, but let me remind you, like, how can you go approaching this question. It's a salt, and for a salt which is like a bivalent cation is like a bivalent anion is there, and total positive negative charge is 2, so n factor for this salt is 2. One of the very important part of this question. Now you need to do what? Find out the molar mass of this compound. This is sodium carbonate and X hydrate. Molar mass will be what? Sodium carbonate is what? 23 into 2, 2 into 23, 1 times of 12, 3 times of 16, X times of 18. 18 is the mass of water molecules. 46 plus 12, 46 plus 12 plus 48. Yaar, 60 plus 46 is 60 plus 46, 106 plus 18x. So this is the molar mass of the substance, and the equivalent mass will be just divided by 2. So let's say if I find the equivalent mass of this compound Na2CO3 dot X hydrate will be 106 plus 18x by 2, which is the n factor. So it will give you 58, right? Not 58, this will be 53 plus 9x. So normality is 0.1. What is the formula of normality, everybody? Have you ever tried it? The formula of normality is given mass upon molar mass or equivalent mass, sorry. So 1.43 upon the equivalent mass is 53 plus 9x into this is the number of moles into 1000 upon volume. Volume is how much in milliliter? 100. This will come up as 10, and normality is also given to us, which is 0.1. So what you will be getting? 5.3 plus 0.9x is equals to 14.3. So 0.9x comes up as 9 only, x comes up as 10. So this is decahydrate, everyone. X value is 10. This was a good question, and I wanted you people to attempt this question, because see, being a teacher, or like I've been teaching from past few years, and among this year I have got this confidence that, let's say this is redox reaction. So the moment the redox reaction comes in my mind, it's like, oh, easy chapter. So let it be the difficult question of this chapter that it was. We can do it very easily. It's a mixed of some concepts of mole concept and then normality and then molarity. We anyhow made it. And I wanted you people to do it, and those whoever will be doing these questions later on, do mention and always be very attentive, like how I proceed to this question. My way of approaching is not as a teacher, it's always as a student, that I try to solve the question just like you people do, and how fast I go, how quickly I basically get the concept. So that is very important to us, right? And that's the beauty of this entire concept, everyone. Like whenever I come up with these kind of series with PYQs of 2020, like whenever I come with the PYQs of 2002 to 2024, and all of these questions, I see these questions once only when I get through this PPT, identifying whether any question is incorrect over there or not. This moment is the only time I see the question. I always make these questions unseen to me, so that while solving the problem in front of you, it can become very like amusing to me also, and some excitement also is there to solve these questions. But I want you people also to gain the same confidence and get the same boost while solving this question. We have another question. 10 is absolutely correct answer. The next question says that in order to oxidize a mixture of 1 mole of iron oxalate whole thrice, FeSO4 and FeDis acidic medium, number of moles of KMnO4 required. So first of all, you take this thing in your mind. 1 mole of each of them we are taking. So let's see how is this thing related to number of moles of KMnO4, and how we see So gram equivalent of oxidizing agent must be equals to gram equivalent of reducing agent. So these all things are actually reducing agents, and KMnO4 is an oxidizing agent, we all know. So for an oxidizing agent, the N factor is pretty much fixed, which is 5, and here number of moles of KMnO4 required, number of moles of here KMnO4 into N factor is 5, and then we'll get the number of moles of this, and it has been given 1 only, and then comes the N factor of reducing agent, right? So anyways, we can say that number of moles of KMnO4 whatever we are using is directly proportional to the N factor of the reducing agent we are taking. So whoever will be having the highest N factor will be having the most, will require most number of KMnO4. So let's start it from FeC2O4. So guys, this is your +2, this is in +3, and under oxidizing conditions this will go to Fe3+, it will go to CO2. The N factor comes up as it's typical oxidation for all of them, so it will be like 2 + 1, it is 3. Second is Fe2C2O4 whole thrice. Iron is already in +3, it will not be further oxidized, it will only give you CO2, which will be an oxidized product. Check out this oxidation state of carbon is +3 and it goes to +4, and how many carbon can you see? 3 into 2 is 6, and the change is of 1, 6 only, right? So N factor will come up as 6. Check out the further reactions. One of them is iron sulfate. So FeSO4 has +2 on oxidation. Sulfur is already in maximum oxidation state, won't be oxidized further. So just the N factor will become 1. And the final part is FeSO4 whole thrice, in which sulfur is also in +6, it is also in +3. So basically no oxidation occurs here. So you cannot identify the N factor. So what do you think? How many moles of this are used? Okay. So number of moles of KMnO4 required is, oh my god, you got to add all of them or what? Number of moles. Okay, fine. So 1 mole of each we are taking. So guys, do one thing. We can use this funda, that for each one of them we can say the gram equivalents of this will be total. So you can add up all of them. 1 mole of each is being given over here. So this is like number of moles of KMnO4 will be equals to. So you can count down the N factors. 1 is the common. N factor will be what? For the very first part you see the N factor is 3, then 6, and then 1, and then 0 only. It is not further oxidized. So this whole divided by what? 5 is the correct answer. I think C is the correct answer. What do you think? I guess this question is a good question. It's a very beautiful question we had. And why is it so? Because this question has cleared so many concepts till here, and C is the perfect answer. And I sometimes feel very very proud solving these questions very easily and just like in seconds. And I want you people also to gain the same confidence, like yes sir, we also can do it, we are your students. We have another question here, the hardness of water. Okay, hardness of water is a something different topic, but anyways, let's see how do we approach the hardness of water in a sample containing 10⁻³ molar calcium sulfate. Molar mass is given to us. Okay. Do you know how do we measure the hardness of water? It is usually measured using sodium carbonate. Using sodium carbonate. So how much amount of calcium carbonate do we get by this reaction? CaCO3 plus Na2CO3, and the reaction takes place in this way. Maybe this question might be a bit difficult to you as of now, because you might have not undergone hardness of water or calculation of it, but if you get this concept from me, then it will become very easy question to you. You need to just apply the concept of molarity only, and not just molarity, parts per million. This is something which we have already discussed in our previously we have discussed it. So CaCO3 plus Na2CO3 gives you Na. Now what we are doing is CaSO4 on reaction with sodium carbonate. This is a process of removal of permanent hardness. This will become CaCO3 plus plus how much do we get of NaSO4, Na2SO4. So this will be, this is something that will keep on this settles down, and now we'll find out how much mass is there, and this is 10 to the power minus 3 molar, and no doubt if it is 10 to the power minus 3 molar, this will also be 10 to the power minus 3 molar. Then you can find out ppm, parts per million. How? Sir, this 1 liter of the solution is 10 to the power minus 3 moles of calcium carbonate. The mass of calcium carbonate, mass of, let us suppose, water into 10 to the power 6, it is called as the parts per million or degree of hardness. So mass will be 10 to the power minus 3. The molar mass of calcium carbonate is 100 gram per mole, divided by water is like 1 liter, and we can take it 1000 into 100 or into 10 to the power 6. So just solve it. I guess it should come up as 100 parts per million. Let's see the correct answer. $100 is correct. Okay. This concept is pretty easy, but you people might have not gone through it earlier, and in 10th class also you study about the degree of hardness and all. But even if you haven't, you don't worry. There is a chapter, separate chapter by the name of hydrogen in your 11th standard only, that will come across, and where we learn about water, its hardness, permanent and temporary hardness, and removal of hardness, and then degree of hardness. So that question is based upon degree of hardness. So even if you don't know about it, you can skip this question. Not a very big huge problem we are having. Let us skip this question and move forward to the next question. Another question. The volume of 0.1 molar, 1 normal, 0.1 normal diabasic acid is sufficient to neutralize 1 gram of a base that furnishes 0.04 moles of OH minus in aqueous solution. What do you think? Volume of this required to sufficient to neutralize 1 gram of this 0.0 mole of OH minus. So do one thing, that gram equivalent of acid must be equals to gram equivalent of base. So acid has 0.1 normality and volume. This is milligram equivalent, okay, because volume is taken in milliliter. How much is the base here? No need to take the 1 gram and 2 gram, because this directly 0.04 mole is being given, and n factor of OH minus is 1 only. So basically this is also equals to the number of moles of H plus, and this is also equals to the number of moles of OH minus, because H plus and OH minus have their n factors of 1 1. So this is typically equal to number of moles of H plus, this is equal to number of moles of OH minus. Everything is same now. Just solve it and volume will be got. How much volume do we get? I guess the volume comes up as, how much is it by the way? 10/4 only. Something is missing or what? Yeah, we volume diversity equals sufficient 1 gram of the base that furnishes 0.04 moles of OH minus, and volume will be 400 ml, I guess. Okay. We did something wrong here, that if it is milligram equivalent, we have to multiply by 10 to the power 3 here, then it will become what? Millimoles. Then these are two equals. Volume will be how much? Volume will be 400 ml. B is the correct answer. That's it, everyone. That was the concept of equivalence we had. And now moving forward, we have another equivalent, another important concept from this chapter called as balancing of redox. And one of the most important outcome of this chapter, and some part where so many questions have been asked previously, but as we all know, we already have gone through it, and it's the most easy part of this chapter as well. We have a question here, everyone. MnO4 minus, Bi minus, and something is happening. On balancing, we got to find out the value of Z here. We will simply use those species which are undergoing oxidation and reduction. No need to involve water, no need to involve anything else, no need to involve H plus and OH minus as well. We are right now given up with this equation. We also have positive 7 over here, minus 1 over here, 0 over here, or plus 4 over here. So what you will do in the above equation, it is balanced with integer coefficients. The value of Z is what? Do one thing, everyone. We can get the n factors for permanganate the permanganate, the n factor comes up as 3. For iodide ion, the n factor comes up as, अरे यार कहाँ ले जा रहे हो दोस्त? सारे मैं लिखता नहीं हूँ. 1. Cross multiply. So MnO4 minus 3 by 2i minus, sorry, not just 3i, 3 minus 3i minus produces I2 plus MnO2. First of all, do one thing, just balance number of manganese is already balanced, balance iodine. So you put 3 by 2 here. Then apply your balancing of hydrogen. Hydrogen is nowhere in left and right. Then sorry, simply balance oxygen first. Left hand side it has 4, right hand side at 2. So just put 2 H2O. How many hydrogen are there? 4. Just put 4 H plus. We will putting 4 OH minus here and then 4 OH minus here also. So right after solving this equation, you will get your final answer. But the number of OH minus are coming how many? 4. So can we check the correct answer, everyone? Can we check the correct answer? It is 8. So I'll give you the correct answer. Why is it 8, by the way? Because here we have taken 1 MnO4. Getting me? We are taking 1 MnO4. So if you make it 2 MnO4, then you will be getting 8 of OH minus. So correct final equation. Let me write it. Let's not get confused. So with the main equation, but main equation has 2. Main equation has how many MnO4? 2. Make it 2. Then just simply multiply this equation by 2. And then how many OH minus can you get? 8 is the correct answer. See. A pure, perfect example of balancing of redox reactions. We have a similar reaction over here, which we solved in our lecture itself. That this question was appeared in 2024 JEE Main, and this question is a disproportionation reaction based question. We have Cl2, so we'll simply first write those species which are undergoing oxidation and reduction. Not need to require the basic medium and whatever it is. Simply consider that thing in your mind only. This is how it is going. I told you that you should go reversibly whenever a disproportionation reaction is. Always remember, in case of a DP reaction, go reversibly like this. So this will be getting n factor. This is what? Positive 1, 0, minus 1. This is n factor of 1. This also has an n factor of 1. If both of them are having 1, cross multiply them and simply make it Cl2. Gives you ClO minus plus Cl minus. Now what you should do? Find out the number of oxygen here. 1. We will put 1 H2O. We will put 2 OH plus. We will put 2 OH minus here and 2 OH minus here. That's what we do. We balance it until hydrogen is balanced in acidic medium. Then if it is a basic medium, then we will add equal number of OH minus as many as H plus were there. So this is how the reaction works. The final equation will become what? Cl2 plus 2 OH minus gives you ClO minus Cl minus plus 1 H2O. Now check out the correct answer. Check out, everyone, check out. Cl2 is 1, 2 OH minus. I think this is correct. B. Next question is number of moles of H positive ions required by 1 mole of permanganate to oxidize oxalate to CO2. Very simple, yaar. What's happening here? MnO4 minus C2O4 2 minus CO2 Mn2 plus, because we are carrying out this reaction in acidic condition. Okay, this is positive 7, this is positive 3, this is positive 4, this is positive 2. The n factor of permanganate ion is 5. The n factor of oxalate ion is change is 1 and 2 carbon are there, so it will be 2. Cross multiply them, what it will make? 2 times of permanganate ion plus 5 times of C2O4 2 minus equate the number of manganese and CO2 also, so it will become 10 CO2. It will also become 2 times of per manganese ion. It's a basic reaction. Okay, it's asking how many number of H positive are required. Okay, we'll do it. First of all, find out the number of oxygen atoms. Left hand side 8, 8 plus 20, 28. Right hand side 20, so we'll put 8H2. Sure, let me just cross verify. 10 into 2, 20, and here it was 20, 28. So this will give you 16H plus. This is the balanced chemical reaction now. So can I check the correct answer, everyone? Okay, wait. This is also saying 1 mole. Don't get so fast and committing some mistake. So brother, 2 moles of KMnO4 need 16. Then 1 would need how many? Like that. So 1 mole of MnO4 minus needs how many? 8H plus, not 16. Finally, we have made it correct. Correct answer is 8. Look at the answer and just give a round of applause for yourself and for me and for all of us who are right now dedicatedly working on this very beautiful chapter. Acidic medium K2Cr2O7 gives a reaction like this, XYZ, and will be what? Okay, try this question by our own. Cr2O7 2 minus plus. So let it be. We're not supposed to write anything right now. We know that what does this reaction leads to. In acidic condition, it gives you Cr3 plus. So it will become 2Cr3 plus in order to balance the number of chromium atom. It's right now present in positive 6 state and goes to positive 3. One chromium atom accepts 3 electrons. 2 will be accepting 6 electrons. You have to put here 6 electrons. So we have got the number of electrons. That is the value of Y. Now do one thing. Balance the number of oxygen by applying 7H2O and 14H plus. Now this is your balanced chemical equation. It's that simple. It was a half reaction, but now we have made it balanced. Check it out, everyone. How many number of Cr2O7? No, we don't need it. XH plus is 14. Then 14, Y is 6, 14, 6. I think B is correct. B is correct. This part is absolutely clear to all of us. Now let us come to the another question I asked in JEE Main 2023. Haven't you seen that just from 2024 to 2023 we came and so many questions have been asked, not just in 2024 but in 2023 as well. So guys, I personally find that this concept is pretty useful, and balancing is something that is the particular outcome of this chapter. I must recommend you this part of this chapter. Balancing you must know, and specifically I told you that you should follow balancing by oxidation number method, which is the fastest method, like I am doing. Okay, take one more example and we'll do it even more faster. That this is IO3 minus I minus produces I2. Don't need to require H positive, whatever, nothing. So do one thing. I already have spoken with you regarding the same, that whenever these kind of condition is there, this kind of reaction is called as sim proportionation, and sim proportionation reactions are reverse reactions of proportionation. So sim proportionation reactions are opposite of the disproportionation reaction. So what you will do, just go in the forward direction only. Try to find out the oxidation states first, and then this is 0, and find out the n factors. 5 to 0, this is n factor is 5, and minus 1 to 0, the n factor is 1. Then cross multiply it. Okay, cross multiply it. It will become, after cross multiplication, it will become what? IO3 minus 5I minus and then I2. So I2, multiply I2 with a suitable number to make iodine equal in both of the sides. I think it is 3. Now it is a balanced reaction in terms of iodine, and in the terms of electrons gained and lost are equal. Do one thing, in order to balance the oxygen, put 3 water over here. And acidic condition is then, so 6H positive will be coming over here. This is now a balanced chemical equation. If you want to cross check it, just simply do the count of all charges. -1, 6, 0. Here also it is 0. 0 charge left hand side and right hand side. What has been asked here? Value of X, any how many I minus were there? How many I minus you see? I don't know, man. Why, man? Why? Okay. Yeah. So guys, now look at the question. How many number of iodide is given? 2. So if you multiply this whole reaction with 2, then this will become what? 2 times of iodate, 10 times of iodide, 12 times of H positive, and gives you, and so on. So correct answer should be 10. A is the correct answer. One more similar question came in 2023. See the following chemical reaction and find XYZ. So I now can recommend you these questions to solve it by your own, because you already have known the process and the method to solve it. However, if you face any kind of doubt, do let me know. I can help you anytime you want. So this is Fe2 plus, Fe3 plus. This reaction is something that we have solved in our class also, and the theoretical class also. So do one thing, Cr2O7. So this is positive 6, this is positive 2, this is positive 3, and this is positive 3. So n factor is 6 here. So cross multiply 6 times of Fe2 plus. N factor of Fe2 plus is 1, so cross multiplication is this, and it will give you 6 Fe3 plus 2 Cr3 plus 2 Cr3 plus. How many water molecules we have to add? 7, because 7 number of oxygen are here. 14 H plus will be added here. This is now your balanced chemical equation. What has been asked, by the way? The sum of x, y, z. How much is the x? X is what, by the way? H plus 14 plus y is chromium 6 plus, and not 6 man, 2. Z is what? Water molecule 7. So 23 is the answer, I guess. What do you think? 23 is very absurd number, but let's see. If 23, man. So this is something which is quite easy to us, solving and even procuring what we want. A question we have that came in JEE Main 2013 offline exam. The question is pretty simple, and we have already solved this question. Meanwhile, let me just take you to that question. Where did we solve this equation? We won't require too much of time to waste upon. Maybe this. No. This was the question, right? See, oxalate ion MnO4. So what we get, by the way, in this reaction, we get 2 MnO4, 5 C2O4, 16 H2O. So let me write the correct balanced chemical equation directly, as we have already done it. I have the values in my mind as well. We got it 2 MnO4 minus, so plus, now I forgot it, 5 C2O4 2 minus plus 16 H plus gives you 2 Mn2 plus 10 CO2 plus 8 H2O. So using this data, how much X do you get? Y and Z by 2 is equals to 8. So Z is 16. So 2, 5, 16. C, most probably C. So that's how we do it. Probably the last topic of the day, everybody. Probably the last topic of the day, the final topic of the day we have, and this is called as redox titration. So let's welcome redox titration. And allow me a moment, everyone. Okay, so let's come to this question, which is from redox titration. The very first question is here that only 2 milliliter of KMnO4 solution of unknown molarity is required to reach to the end point of a titration of 20 milliliter of oxalic acid in acidic medium. The molarity of KMnO4 solution should be what? So we got to find out the molarity of KMnO4 solution. So how we should do it? Only 2 ml of KMnO4 solution of unknown molarity is required to reach the end point of the titration. 20 ml of oxalic acid is given to us. Molarity of KMnO4. So do one thing. Gram equivalent of KMnO4 must be equals to gram equivalent of oxalic acid. And you must know this is not an acid-base reaction. This is a redox reaction. How does the reaction work? KMnO4 minus reaction reacts with oxalic acid C2O4 2 minus. The reaction takes place in acidic conditions, yielding Mn2 positive plus CO2. So N factors are pretty much known to us. In this reaction, the N factor of KMnO4 is 5 and N factor of C2O4 2 minus or oxalic acid is 2. So just try using that. 2 ml KMnO4 solution is used into molarity is unknown, and then N factor is 5 must be equals to oxalic acid has what? What details of oxalic acid do we have? 20 ml molarity 2 molar, and then 2 is the N factor. So now molarity will be this whole divided by 10. So it will be 2 into 2 into 2. I think 8 is the correct answer. Can we check out the correct answer? 8 molar is correct. So guys, all you need is the confidence. You already have visited our theoretical chapter. Everything what you want to know is already with you. Formula we have, concepts we have. Just try to implement your things and get correct solutions out of it. This is it. Next we have given below are two statements. Statement number 1, in redox titration the indicator used are sensitive to change in pH solution, and in acid base titration the indicator used are change in oxidation potential. Okay, let me just recheck it. Redox titration indicators are sensitive pH. Okay, this is I think opposite of this has been used, right? Opposite, because in acid base titration we need pH sensitive, and in acid base indicator use what? We use oxidation potential. Both statement are incorrect. Correct. A is the correct answer. I got shocked like how come these are correct, but these all are incorrect. Both of the statements are incorrect here. There we have the next problem, the next numerical, that JEE Main 2023. This question was asked in alkaline medium. The reduction of permanganate ion involves a gain of how many electron? So you must know the reaction. I already have given you, and I told you by that time only that these reactions are highly important. So permanganate ion under basic conditions goes to Mn4 plus MnO2. No, but this is strongly alkaline, so I guess this is Mn of MnO4 2 minus, positive 6, positive 7. I think I should check this reaction first and then I'll come to you, because alkaline versus strictly alkaline I didn't know, and I think this is what they are talking about. It's normal alkaline medium. If it is written in strong alkaline medium, then we used to take this reaction. In normal alkaline medium, the MnO4 minus goes in neutral or weakly alkaline medium. Neutral or weakly alkaline medium, this reaction goes to formation of Mn. The reduction of permanganate anion, MnO4 2 minus. So this is positive 7 and this is positive 6. No, yaar, again I did the same mistake. This is MnO2. This is in plus 4. So how it is going to plus 4? By accepting 3 electrons. So the correct answer should be 3. Got it? Next, read out the question first. Density of a monobasic strong acid is this. The volume of its solution required for complete neutralization of 25 ml, and this is what? So molar mass is also given. So do one thing. Let's say the volume be Vml. Vml of acid is used. So you will get the mass of acid here. Mass of acid. How will you get the mass of acid? That density into volume. Density is what? 1.21 kg per liter, and kg per liter, or we can also say 1.21 gram per ml. It's the same thing only, because 1000 gram you can write it, and then 1000 ml, 1000 will be cancelled out. This will give you 1.2. So this is 1.21 multiplied by volume. This much amount of grams of an acid has been given to us. Now what is required? Complete neutralization of 25 ml 0.24 molar NaOH. So required for complete neutralization of 20 ml of 0.24 molar NaOH. The volume of its solution required for the complete neutralization of this mass is given to us. So number of moles of acid into its N factor. It's a monobasic, so N factor will be equals to number of moles of NaOH into its N factor. So acid is 1.21 V into 1 must be equals to number of moles of NaOH are how many? 0.24 molarity into 25 milliliter into N factor is 1 is equals to millimoles. Actually we are getting, so this volume might be coming in milliliter here, right? No, this is in gram, and gram, okay, mass divided by molar mass is how much? 24.2. So this is the number of moles, and these are the millimoles. So do one thing, if these are millimole, then also put 10 to the power minus 3. You solve this question, and then you will get the volume V here. Getting me? This is number of moles. Sorry, this is millimoles. So we have applied 10 to the minus 3. Now it has become moles. It is also moles. Solve it, and you will get your value of volume. Right, guys? Next question, please. 12 with the correct answer over there. A compound of an acid, and it is okay. So this kind of question, which is related to the pH and all, this will be doing in will cover in ionic equilibria. This part of the chapter will be covered in ionic equilibrium, because this is related to the indicators and what indicator is used in which condition. So right now what we are having is weak acid, and it exhibits a pH equivalence point due to the neutralization NaOH with this. So what we are having is, we are having weak acid versus strong base titration, and the equivalence point appears in basic conditions. Basic conditions as in where pH is nearly 10. So the suitable indicator will be phenolphthalein. Methyl orange is a base, gives you color change in acidic condition like 3 to 4. Methyl orange same, methyl red also similar 4 to 5. This is enrich, what is it? Erichrome black tea. Leave it, we got the answer C. Don't focus on what we don't know, focus on what we know and what we can get out of it, how we can use it productively for us. Okay, so it's a question, we use this question. I remember exactly like when I was teaching you this chapter. So in this, this is called as iodometric titration. The question is 20 milliliter of 0.02 molar hypo solution is used in titration of 10 ml copper sulfate. The presence of excess of KIs and starch is an indicator of the molarity of copper 2 plus. Guys, I can do it very simply, that whatever the flow of reaction is there, we all know the gram equivalent of each and every components are similar and same. So gram equivalent over here of copper 2 plus must be equals to the gram equivalent of the one for which idea has been given, which is hypo. We know the hypo solution Na2S2O3 goes to Na2S4O6, and in which its n factor comes up as 1. Its n factor comes up as 1, 2 to 2.5, 0.5 into 2. Anyways, for copper, what we need to find out is molarity. So molarity into, first of all, use this reaction, everybody. How much n factor are we getting? This is your plus 2, this is going to plus 1. So I think the n factor is 1. So simply 1 must be equals to, so molarity into volume, okay, 10 ml is there, no, 10 ml into molarity into n factor is 1 is equals to, hypo solution we have 20 ml, molarity is 0.02, 20 ml, and n factor will be what? Na2S2O3 to that 1. So molarity will be how much? 0.04 molar, and it can be written as 4 into 10 to the power minus 2 molar. So I think 4 is the correct answer. Can we check it? 4, yo. We have another question here. We have a similar question here. The question is, phenolphthalein is a pH indicator and it remains colorless in acidic condition. It gives a pink color in basic medium, which is true. Phenolphthalein is a weak acid and it doesn't dissociate in basic medium. It is wrong. It dissociates in basic medium only. So A is correct, B is false, C is right. Correct. A is true, B is false. Reason is false. 10 ml of 0.05 molar KMnO4 solution was consumed in the titration. 10 ml of oxalic acid dihydrate. The strength of the solution is what? Gram per ml. Another very easy question, by the way. Oxalic acid dihydrate is H2C2O4 2H2O dihydrate. Now you'll do one thing, that 10 milliliter of 0.05 molar KMnO4 solution was consumed in a titration. 10 ml of the given oxalic acid dihydrate. Strength of the solution we have to tell. Do it in this way, that 10 ml of this solution was consumed in titration. So what are we gonna to do is titration of this. First of all, we'll do gram equivalent of KMnO4 must be equals to gram equivalent of H2C2O4 dot XH2, 10 ml into its molarity into n factor is 5 must be equals to, volume is given to us, molarity is unknown. Okay, so molarity is unknown into 10 ml, n factor is 2. So molarity comes up as how much? 10 cancelled out, 0.25 by 2, 0.125 mole liter inverse. Now you got the moles here in 1 liter and you have to find out how much mole mass is there. So strength of oxalic acid will be equals to molarity into molar mass of oxalic acid, because this is moles in 1 liter. Mass in 1 liter will be what? Multiplied with the molar mass. It's that simple. First you find out the molar mass of H2C2O4 dot 2H2O. How much does it come? So it is like 2 plus 12 दूनी 24 plus 16 चौके 64 plus 18 दूनी 36. Solve it, guys. 126 gram per mole. So 126 into 0.125. Now this is the mass of oxalic acid in 1 liter solution we are getting. Now you can find out. I think this is written 1 into 1 by 8. Solve it and you'll get your answer. I can check the correct answer. 1575. 15.75. 15.75 gram per liter. So 15.75 can be written as 1575. It's me only who is doing the all questions, but I must say that buddies, these are questions which should be done by you. Maybe not now, but once you cover all this chapter, please try to solve the questions with yourself, and then you will be getting how we are doing it. So now again, this is very another question of NaOH and N2CO3 in some impurity. So guys, this is a part of double titration. This is a part of double titration, and we'll cover in ionic equilibrium only. We'll cover in ionic equilibrium only. And the next one is another very easy question, that volume in milliliter of 0.02 molar K2CO2 required to react with 0. This is ferrous oxalate in medium. So everything is pretty simple. Ferrous oxalate is what? I'll give you the idea, you applied by your own. Okay, so we have the reaction is somehow like this: Cr2O7 2- plus ferrous oxalate is FeC2O4. The reaction leads it to the formation of, in acidic conditions, this goes Cr3 positive, because in basic medium it doesn't behave as an oxidizing agent, so nothing will happen. This will be 3+ and Fe3+ plus CO2. So without wasting our time, let me just give you an idea that n factor for this will be 6, n factor for this will be 1 plus 2, 3. So now you just apply this concept of gram equivalent of Cr2O7 2- must be equals to gram equivalent of FeC2O4. If you do it, you will be getting your answer. Next is, while titrating, dilute HCl with NaOH. Which of the following will not be required? Pipette and distilled water, clamp and phenolphthalein, burette and porcelain tile, Bunsen burner, and I think D shayad. Bunsen burner is not required now, because this is already an exothermic reaction. The reaction acid base is an exothermic. Acid base reaction is an exothermic reaction. Do not require Bunsen burner. It doesn't require any burner. Next is 50 ml of oxalic acid needed to neutralize 25 ml of sodium hydroxide solution. Amount of NaOH will it be used? So it's an acid base titration. First of all, remember, it's an acid base titration. So it's simple that gram equivalent of oxalic acid C2H2C2O4 must be equals to gram equivalent of NaOH. So how much H2C2O4 are there? 50 ml of 0.5 molar needed to neutralize 25 ml of this. So 25 ml multiplied by 50 ml of this is required to neutralize 25 ml of this solution. The amount of NaOH in 50 ml of the solution is what? So first of all, let us know what is the molarity of the solution. So let's say M is the molarity. N factor is just 1. For oxalic acid, 50 ml 0.5 molarity into N factor is 2. So there you will be getting 100. This is like 50. Molarity is like 50 by 25 is 2 molar. So what you are getting is that 1000 ml solution has 2 moles. So 25 ml solution of NaOH will have what? No, 50 ml we have to find out. No, in 50 ml. So 50 ml will be having how much? 50 ml solution has 2 by 1000 into 50. So I guess this is coming as 0.1 mole. So mass of 0.1 mole NaOH will be moles into molar mass. So 0.1 into 40. So I think 4 gram is the correct answer. Is there any option by 4 gram? B. So B is absolutely correct. And that's it, everyone. We had an amazing lecture today. We had an amazing experience of solving PYQs of 2002 to 2024. Guys, please try it by your own. And we have all India mock test for you held on 19th of January. Please give this exam. It's very important for all of you. And not just this, is also one more thing which you can do. Try to find your all India rank. That is also available on shift wise percentiles which will be appearing in the exam. And there is one more thing that you can do. You can enroll in the Ranker Reward program, which is absolutely free, and just apply, scan it, fill some required information, and once you'll be getting good marks in your just upcoming exam of JEE Main, you will be rewarded. So do it now.